Hello everyone, welcome to another video on writing programs for using Microprocessor 8085 instructions. So we have already discussed some of the programs that we can write using the ISA of 8085, and we have already implemented and executed those instructions using this GNUSim8085 simulator. In this particular video, we will similarly discuss another program using Microprocessor 8085, and we will execute that program in GNUSim8085 simulator. Okay. So before starting, let me reset this particular simulator here. Okay. So what is the program? The program is that we have to find largest element in an array. Okay. That is the aim of this particular project. No, sorry, of this particular video. Okay. So we will write a program using Microprocessor 8085 to find largest element in an array. So this particular array is stored in memory. Let's say, for example, we have some address. Let's take this particular address. This particular address stores the size of array. Okay. Let's say the array contains 5 elements. Okay. And the array is stored from this particular location. So at 0021H, at this address is the first element. Let's say the first element is 10. Then comes the second element at this particular address, that is, let's say 5. The third element at this address, let's say 12. The fourth element at this particular address, let's say 15. And the fifth element at this particular address, let's say 6. Okay. So these are the elements stored in the array, and this is the size of array. So our program should access this array, find the largest element. So what is the largest element? 15. So this is the largest element. And this is stored at address. What is the address? Address is 0024. And in decimal, it is probably it is 36. Okay, 0024. H is 36 in decimal. So we want to find this element, and this largest element, let's say we want to store this largest element at this particular memory address. So this particular memory address should get 15. Okay. And we should also store the address of this element. So what is the address of largest element? 0024. So address is how many bits? 16 bits. So we want to store these 16 bits, 8 bits here and 8 bits here. Okay. So let's say 0, or we can say the higher order bits here and the lower order bits here. So this is in hexadecimal, but in this particular simulator, everything is stored as decimal number. So here we will have stored 36, and this will contain 0. Okay. So this address will be stored at location 0031H. Okay. So this is the aim of our program. So let me first write that program here. So let me load that particular program here. Okay. And I will explain the program. Okay. So this is the program. The program is write a program to find a largest number in an array stored in a memory. The size of the array is stored at memory location. So this particular memory location, it stores the size. the largest element should be stored at location 0030H and the address of the number at 0031H. And there is one additional detail that I have not written here. It is the array elements are stored at location starting from 0021H. Okay, so let's write the algorithm here. So that means the elements are stored from 0021H. It is H here hexadecimal. So let me write the program. So how will we write? The first point will be, the first job will be, we will load this address into our HL register pair. So how will we load this address? Then we will get the size from this memory address into some register. Let's take that register as C. Okay, so move C comma M. So it is saying go to this memory address. What is this memory address? It is the address stored in HL register pair. And what is that address? 0020H. So get that particular value. Let's suppose at that particular value we have stored 5. So get this 5 and place this 5 in C. So our C contains the size of array. Now the third part is, now we will increment this H. Increment this H means now it will point to first element of the array. Okay, now let's place that first element in register B. So that means B contains the data stored at this memory location. Okay. Then fifth is, so let me go here. Fifth is, now what we are going to do? We will decrement this C one by one. So this C we are going to decrement. Why we have to decrement this C? Because we want to check the elements. How many elements? What will be the size of array? So we will decrement this C one by one till we reach to the 0. So let's decrement this C. Okay. So we have decremented C. So C is keeping the count how many elements we have checked. So we have already checked one element, the element that we have moved to the B. So that is why we are decrementing C. Now we have to go to the next element. So our HL register pair was pointing to this address. Now we have to go to the next element. So that means we have to increment HL pair. So we will write increment H. So now this HL is pointing to next element. 0022, the element stored at 0022. We will get that element and put that element in A. So now A contains this particular value, B contains this particular value. The first element is contained in B, second element is contained in A. Now first we will compare these two elements. Okay, so we will compare B. What is the meaning of compare B? Compare B means we will calculate A minus B. Okay. Now, if A is greater than B, okay, A is greater than B, then carry flag will be reset. However, if A is less than B, carry flag will be set. Because if A is less than B, it will result in borrow, and borrow creates a carry equal to 1. So after comparing B, we will check the carry flag. If the carry flag is set, what does that mean? That means B is greater than A. So we will keep the assumption that B contains the largest element. Initially, B contains the first element, and first element, we assume first element is the largest. Now we will compare that first element with other elements. So initially B contains the largest element. Now we are comparing B with A. Now if carry flag is set, that means B is greater than A. So that means we don't have to change the largest element because B is greater than A. B is itself the largest element. Then in that case, what we have to do? So in this particular case, if carry flag is set, what we have to do? We have to move to next element. Next. Okay, so that means this particular element, the element to which A was pointing, we have to skip. Okay, so we can also say we have to skip this element, go to next element. However, if this is the case, that means A is greater than B, then in that case, what we have to do? We have to put the value of A in B, because now A is greater than B. A is now the largest value. So in that case, we have to move the value of A to B. Now B contains the largest. Also, we will store this address because this address points to the largest element now. We will store this address at this memory location, 0031. Okay. So how will we store this? For this, we will write this instruction. SHLD 0031. It is saying this instruction, SHLD. It is saying store the HL register pair at this particular address. So it will store at this address and at this address, 0031 and 0032. Okay. So let me write the instructions here. So if this is the case, so we will use this instruction, jump C. So if carry flag is set, we will skip. Skip means go to next, go to the next one. Okay, fine. However, if it is not, that means carry flag is not set. What we have to do? We will store HL register pair at this location, and we will also move B to. Okay, so let me write it here with clear terms. So what I have to write, that if compare B, then we have to do jump C, skip. And if that is not the case, then we have to do SHLD 0031H and move B comma. Now let's see if there is a skip. So at this skip location, what we have to write? Skip means go to next point. So when we have to go, we have to decrement C, because decrement C means now we are moving to another one, another point. Okay, and at this particular point, we have to check if this has become 0. Okay, so if it is not 0, we have to repeat the same thing. What we have to repeat? We have to repeat these points. Okay, so it is saying if it is not 0, then go to this particular point. So let's name this as loop. So then go to loop. Okay. However, if C has become 0, so that means we have ended the entire procedure. Then in that case, our B will contain the largest element and HL will be pointing to largest number. Okay. So in that case, or not, B will contain the largest point. So simply what we will do, we will store this in, we will take this value, this 0030H. We will place this value in HL register pair, and at this location we will store the largest element. The largest element is in B. So we will do move M comma B and halt. Okay, that will be the complete step. Now also, if there is only one element in the array, only one element, if the size of array is only one element, so what it will do, so this instruction will be executed, this instruction will be executed, this will be executed, this will be executed. Okay, decrement C will be executed. Now it will go here, this will be executed, this will be executed, this will be executed. Okay, so these all instructions will be executed, but here it will simply skip and go to the end. Only you have to add one extra instruction here, SHLD0031H. Why we are adding this instruction here? So we have to add this instruction here because if the first element is largest, or we can skip, this is not required. So this instruction is not required. So let me skip this instruction. So this is the entire program that is used to find a largest element in an array. Okay, so we are checking element by element. Okay, and whenever we are finding the largest element, we are storing that largest element in B, and we are also storing the address in memory. Okay, so storing the address in memory, we are doing it repeatedly, addressing in memory, but we are storing the largest element in memory only at the end. Okay, so you have to remember it. Fine. So this is the complete, we can say, the description of this program. Okay. The same program is written here. Fine. Now let me execute this program and let's see whether we are getting the correct output. Okay. So let's store the size at 0020H. So what is that address? 0020. So 0020 will be 32. So at 32 we will store the size. Okay, at the 0021, that is 33. From 33 we will store the array elements. So let's write the array elements. 33 at 34, let's write 17. At 35, let's write 11. At 36, let's just write 1. And at 37, let's write 4. So you can see this is the size. At 32 we have the size, at 33 we have 10, then 17, 11, 1 and 4. So among these 5 elements, which one is the largest? This 17. So at the end, this 17 should be stored at memory location 0030, and it is address 34 in decimal. It will be stored at 0031. Okay, so let me execute this program and let's see. Assemble. So always remember, we have to write here the load address where we want to load this program. Assemble, now execute. Okay, so after execution we have to check 0030. So this is 0030, it contains 17. 17 was the largest, and 0031 contains the address. What is the address? 34. You can check here also. 17 was having address 34. So this program makes you understand how we can find the largest element in an array. Okay, so this was all about today's video. But after completing this video, I have to give you some of the programs that you should write on your own. The first part is find the smallest element in an array. So it is similar to this particular program, only some changes. Then after finding the largest and smallest, your job is to do sort an array in first ascending order and second. So you have to write separate programs. One, sort an array in ascending order, and another sort an array in descending. And the third program that you have to write is write a program to find the element with maximum frequency. Maximum frequency in an array. So you have to find an element that has been repeated maximum times into an array. So assume, so in this you have to make an assumption only one element has maximum frequency. Okay, to make the program simple. So these are the three programs that you should write on your own and then execute those programs using GNUSim8085 microprocessor. So this was all about today's video. We will meet again in the next video where we will be discussing about the counters, how we can implement counters using microprocessor 8085. So let me stop this particular video here. Let's meet in the next video. Till then, goodbye.